Hi there, friends. My name is Dr. Marissa May. In this video, we're going to look at solving limits analytically. Now, remember, with a limit, the first thing you want to try to do is just to take that value that x is approaching and substitute it. So I've got 5 times 3 plus 2 and 2 times 3 minus 3. So on top, 5 times 3 is 15 plus 2 is 17. And on the bottom, 2 times 3 is 6. 6 minus 3 is 3. That's pretty simple, but that's the answer for that limit. Sorry about that, friends. I needed to change that problem because it actually wasn't working the way I wanted it to. So let's look at the problem here with the second one. If I substitute -3 in for x, you'll notice that I get 9 plus -12 plus 3, which is 0. And on the bottom, I get 9 plus -6 minus 3, which is also 0. So substitution doesn't yield me a value. When that happens, I have to go for one of my other strategies. So my next strategy is to factor. See if I can factor the top and the bottom. Now on the top, that factors to x plus 3 times x plus 1. And on the bottom, that factors to x plus 3 times x minus 1. Notice the x minus 3 cancel out. That leaves me with the limit as x approaches -3 of x plus 1 over x minus 1. Now we substitute. So if I put in -3 for x now, I'll get -2 on top, and on the bottom, I'll get -4, which tells me I can reduce to 1/2. So this limit actually equals 1/2. Because I was able to factor and cancel out, then I was able to do the substitution again. Let's look at another problem that asks us to do a little bit of factoring. If you see here at the limit on the left, I can't substitute in the 3/2 because again, I get that 0 over 0. We call that an indeterminate form. But I need to factor. So I have to use my difference of cubes factoring pattern. You may be saying, what? I don't remember that one. Well, friends, here it is. Because it is used quite often with limits, I like to remind students of it. I'm even going to give you the sum pattern because I want you to see that they're very similar. So I always taught my students that when you factor a difference or sum of cubes, it makes a little parentheses and a big one. You see that, right? The sign in the little parentheses stays the same as the sign of the problem. The sign in the big parentheses, the first sign in the big parentheses is the opposite of the little parentheses sign. And then the last sign in the big parentheses is always a plus, okay? So if I am factoring this 8x cubed minus 27, then to make my little parentheses, that would be 2x minus 3. Notice I took just the cube roots of those. Times the big parentheses would be 4x to the second plus 6x plus 9. And the whole idea is that we needed that 2x minus 3 to cancel, and it does. That's good. So I'm left with the limit as x approaches 3/2 of this 4x to the second plus 6x plus 9. Now I can substitute. So I'm going to substitute the 3/2 in for x. And I'll need to do a little bit of simplifying. So think about the 3/2 being 9/4. And it looks like I've got 9 plus 9 plus 9, and that is 27. So that limit gives me 27. But I bring this one up because of that sum and difference of cubes. We see it happen a lot with limits, and we want to remind you of that pattern. Let's take a look at the next limit that asks us to use a square root. So when you have a square root in your problem, you're going to need to rationalize. So that just means you're going to multiply the top and the bottom of your square root by the terms that have the square root. Notice that's the top in this case, but we're going to change the sign. So instead of the minus, we're going to multiply by these terms with a plus between them. We formally call that the conjugate. And let me create some space here. When we multiply the top, I want you to see that this is a difference of two squares. The beauty of that is that the square roots go away. So when you multiply it out, you're going to get the x plus 1 minus 4. And on the bottom, be sure and use parentheses here, but you don't need to multiply those out. In fact, I wouldn't. You may be saying, well, why wouldn't you? And that's because look what happens on the top. I want you to see that those terms on the top simplified to x minus 3. And now we can cancel the x minus 3 that's in the denominator. You're saying, does that happen all the time? Yes, it does. The whole purpose of the rationalizing. Now, when you cancel the x minus 3's, you lose any terms on the top, but you need a placeholder there, and that's a 1. So now you have on the bottom just the square root of x plus 1 plus 2, and now you can do your substitution. So you've got 1 on top, you've got the square root of 3 plus 1 plus 2. So you've got 1 over square root of 4 is 2 plus 2, and you've got 1/4 as your final value for this limit. Okay. This is a technique that I use every single time. If my limit has a square root in it, I multiply top and bottom by the conjugate. Look for the difference of two squares that are going to create that term that you can cancel top and bottom.